Before we do some examples, let's do a quick review of the unit circle. Now, remembering that angles formed moving anti-clockwise, for those people that forget what anti-clockwise is, that's going that way, around the circumference of a unit circle are defined as positive. Angles formed by moving clockwise around the circumference of a unit circle are defined as negative. When we look at our unit circle, quadrant 1 is in the positive XY quadrant, then we go in the anti-clockwise direction labeling. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now when looking at our reference angle, we're looking at the first quadrant. So that is this theta here. So if we're in our second quadrant, we're going all the way around to here, which is 180 minus theta, because 180 is all the way around and then back theta, so that's 180 minus theta. If we're in our third quadrant, we're going all the way around to here, so that's 180 plus theta. And if we're in our fourth quadrant, all the way around to there, then that's 360 minus theta. So you have to remember what angle you're looking at in regards to the reference angle. So as a quick reminder, theta, 180 minus theta, 180 plus theta, 360 minus theta. So let's look at the example. We'll use vector v is 2i plus 2j, which is what I've got in these 4 diagrams. So if I go from the origin for 2i plus 2j, so that's my 0 point, that means this point is 2i. And this is 2j. So that means this length is 2, that length is 2. If that's my theta, then to work out what my magnitude of the vector is, that's going to be using Pythagoras, the square root of 2 squared plus 2 squared, square root of 4 plus 4, which is the square root of 8. Simplifying that, square root of 4 times the square root of 2, which is 2 root 2. So that's the magnitude of my vector. In order to work out what theta is, opposite my right angle's here, so that's my hypotenuse and there's my adjacent. So we've got tan theta is opposite over adjacent. Tan theta is 2 over 2, which is 1. So theta is inverse tan of 1, which is 45 degrees. So that's the information that we're going to use in these examples. So let's look at each example. The vector 2i plus 2j, x is positive, y is positive, so we're in our first quadrant. That means we're just going to deal with theta. Polar form is r theta, and we worked out that r was 2 root 2 and theta was 45 degrees. Now in the next one I have negative 2i plus 2j. So now x is negative, y is positive, so we're in our second quadrant. So that means we need to deal with 180 minus theta. So that's going to be 180 minus 45, which is 135 degrees. So our polar form is going to be the 2 root 2 and 135 degrees. Now I don't have one for my third quadrant, but if I was in the third quadrant, put it up here, that would be x is negative and y is negative. So I would have to do 180 plus theta, which is 180 plus 45, which is 225 degrees. So my polar form would be equal to 2 root 2, 225 degrees. Last one, I've got 2i minus 2j. So x is positive, y is negative. So I'm in my fourth quadrant. Now we have two options here. We can go, as in this first diagram, 360 minus theta, which is 360 minus 45, which is 315 degrees. So my polar form would be my 2 root 2, 315 degrees. The other way of doing it is using theta as a negative. So this angle here is negative 45 degrees. So my polar form in this sense would be 2 root 2 negative 45 degrees. Now in specialist maths, we normally have theta as being greater than 180 degrees, less than and equal to 180 degrees. Don't get too caught up in this, we'll do it as we go, but that means in first and second quadrant we'll have theta as positive, so we'll be dealing with theta and 180 minus theta. And for our third and fourth quadrant, we'll do theta as negative. But more on that later. We'll do a lot of that as we work through Unit 1.